maximum modulus theorem. So today I'm going to take up the first version, which says that uh, let f be a function defined on G, and f is of course analytic. This G is a region. Region means it is open and connected. Also, let there exist some A in G. It means there is some element in G such that mod of fz is less than equal to mod of fa for all z in G. So class, let's have a quick interpretation of this condition 1. It means that the function is bounded on G, because as you can see that the values of the function for all elements in G is smaller than this number. And moreover, class, you can see that this number is one of the values of the function. The value is being attained by the function at A. So it means the given condition 1 says that number 1, the given function is bounded, and moreover it attains its bound. This number is behaving as its bound, and because we are getting this number as the value of the function at some point A of the domain, it means the bound is attained. So we are given this, that function is analytic, it is defined on open and connected set, function is bounded, and it is attaining its bound. So if we have this information about a function, then class, we are going to get something very surprising, which we don't have for real valued functions. And class, let me tell you that it's really difficult if we try to analyze it. So far as the mathematical computations are concerned, mathematical logic is concerned, certainly with the help of mathematical logic, we will establish this fact. So certainly mathematically it's a correct fact. But to visualize it is really difficult. So right now, being in online mode and even otherwise also, I don't find myself to I don't find myself in a position to make you visualize the result, the consequence of this theorem. And I mean the consequence of this theorem, which you will be able to see just now in this next line. So if we have a function f with all these properties, then class, this result says that this f must be a constant function. So class, this is something very contrary to the frame of real valued functions. Because if you recall, I mean, there are several functions. For example, I take, let us say, this function, fx is equal to sine x. Then class, you know that the real line R is open as well as connected. This function f is differentiable on the whole of the real line. Moreover, class, this function is bounded as well. This is bounded by 1. You know this?
Yes, sir.
Right? And
Yes.
moreover, 1 can be identified as, for example, modulus of the value of f at pi by 2 or at minus pi by 2 or likewise. So Here this pi by 2 is serving the purpose of, let us say, A. Is this okay?
Yes, yes.
Right? So I mean, if you want to have some sort of uniqueness, so what you could do, instead of the real line, you just take open interval 0 to pi. So still the function is bounded, and you will have exactly this situation. And certainly you can see clearly that function f is not a constant function,
I understand it.
right? So I mean, uh, so this kind of situation we don't have in the case of real valued functions, but surprisingly in the case of complex valued functions we have this situation. So that's why, class, I'm saying that in the case of real valued functions we have this situation. In the case of complex valued functions, mathematically it is established. We shall be writing down the technical details, but I don't know that how I should convince you that I mean, of course, with the help of some one or two examples, I can try to convince you, but that will not be sufficient. I know that. So there's something very strange, contrary to the study of real valued functions we have here in the frame of complex valued functions. So that is all about this maximum modulus theorems. Okay, class, an alternate statement for this can be the following, or in short, I can say that a non-constant, now what you call as the negation of the above statement, a non-constant function, when I'm saying a non-constant function, I'm saying a non-constant complex valued function. Of course, analytic, that condition is there. I am writing this statement in short. A non-constant complex valued function can't attain its bound. Because if you have a complex valued function and it attains its bound, then it must be constant. Of course, that is understood that the function which we are taking or will be taking is, we will have to take an analytic function. This will be these will be the conditions of the domain. All that is understood while I am writing this statement in brief. So always remember, if you have a non-constant analytic function defined on an open and connected set, then it can never attain its bounds, because in case it attains its bound, it has to be
Constant.
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 right. Okay, class, let's start with the proof. Astha, yes, Astha, you joined just now. Astha,
Yes, sir.
are you in section D?
Yes, sir.
Okay. So, are you attending my class first time?
No, sir.
So, earlier I never noticed it that I had to give you the joining, but this time, are you joining it from some different email ID or some other reason? Yes,
No, sir. Same email ID.
email ID, but it is the first time when your joining pinged in and I had to give you the joining. I don't know.
Um, Sir, I have
Anything.
two email IDs, so it could be some other email ID that I have joined earlier.
Take it easy. Take it easy. Let's continue. Take it
Okay.
easy. No issue.
So, the function which we are here taking, the range has to be C, or it is just a codomain.
Uh, it is just codomain. It is just codomain. There is no need. I mean, when you are saying that range is to be C, it means you are perhaps trying to say that the function should be onto. right?
Yes, yes.
The moment we say that range should be C, it means we are expecting this function from G onto C, right?
Yes,
No,
sir.
we don't require the function to be onto. I mean, there is no need that the range of the function must be equal to C itself. There is no need of that, right?
Okay, sir.
Is this okay? Fine, good enough. Nevertheless, I should mention that certainly this G is a subset of C. I should mention this. That is though that is understood. Okay, fine, good enough. So class, let's start with the details. And we have uh, a lengthy proof, but we shall be doing the proof in parts. So to that, I'm starting with this. We are given that A is in G, right class? And G is open. So using the fact that G is open, it means class that there exist some R greater than 0 such that the ball centered at A with radius R will be fully sitting inside G. We have simply used the definition of G being an open set. Is this okay, class?
Yes, sir.
Okay. Now let us take some R such that R is of course greater than 0 and is strictly less than capital R. Any arbitrary small r which is strictly smaller than capital R. So that, and the arrangement which we are making is the following, that the corresponding closed ball, this, please take a note. It does not, this notation stands for the closure, this stands for the closed ball, corresponding closed ball. And if I take this notation, then this will stand for closure of it. Is this okay, class?
Yes, sir. Clear.
So there should be no confusion. Okay, so that uh, the corresponding closed ball still sits inside this. We choose a small r like that. So we can always do this. So class, our first aim is to show that our first aim is uh, uh, to show that, sorry, we will go a little slowly, show that f is constant on BAR. So class, first I will show that f is constant on on BAR, and then I will extend this feature of f onto the full G, because we are to show that f is constant on G, right class? Okay. So class, consider this circle which is centered at A and having radius R. Class, take a note. This R is same as this R. I am using this R here, uh, such that this is. I hope you understand that this gamma will be nothing but this circle, the center A, and the radius R. So I am talking of this circle, right, class? This is gamma. Is this okay?
Yes, sir.
Okay, fine. So let us consider this circle, class. Class, then the value of f at A will be equal to 2 pi I, the value of this integral z minus a dz. I hope uh, you must have got it immediately that what I have done. I have just used
What's the integral?
Yes, Cauchy's integral formula by Cauchy's integral. Is this okay, class? Therefore, uh, mod of Fa will be equal to mod of 1 upon 2 pi I gamma of z divided by z minus a dz, its modulus. It will be further less than equal to class 1 upon 2 pi I, because class the modulus of I will be 1, right class? And I am taking this less than equal to because we can take this modulus inside. Is this okay, class?
Yes, sir.
And then we can take the modulus of numerator and denominator separately. Is this okay, class?
Yes, sir.
Right. Now, class, take a note that here these jets on which we are taking this integration, these jets are the elements of this gamma. Yes or no, class? Because you are taking integration over this gamma, right, class?
Yes, sir.
And if you are taking those jets which are on the gamma, so for those jets, what will be mod z minus a?
R.
It will be equal to small r. Good. So class, this is further equal to 1 upon 2 pi. So I can take this r outside the integral sign. This is mod of fz, mod of dz. And now, class, further, uh, this is less than equal to, it has been, now please take a note that b our bar, this is contained inside uh, bar, which is contained inside G. So the ultimate point is that this is contained inside G, right? And we are given that for G, we are given that condition 1 holds. Yes or no, class? For all elements of G, right?
Yes, sir.
Yes, sir.
So in particular, for all elements of this BAR and for all elements of gamma as well, because if you notice, class, this gamma is also sitting inside G. Yes or no? This is also inside G. Is this okay, class? So, so using condition 1, it means this is further less than equal to mod of Fa. And class, I can take that mod of Fa outside the integral sign because that is just a constant. So I have used here condition number 1, the given condition number 1. Is this okay, class? Is this okay, class?
Yes, sir.
And now, class, this is what? This is nothing but the length of the curve gamma, which is nothing but 2 pi r. Is this okay? Is this okay, class?
Yes, sir.
So class, it means what? So class, and now class, this 2 pi r gets cancelled with this 2 pi r. So class, that is, we have the following. That is, let me conclude this above discussion. That is, class, actually I have shown you that mod of Fa is less than equal to 1 upon 2 pi r gamma mod of this dz. So class, take a note. This inequality I have marked here, and this is further less than equal to, class, if you notice, we are having only mod of Fa here. Class, take a note. Now here I have used this inequality. Is this okay, class?
Yes, sir.
So exactly this is what we have shown in this above, uh, in these above details. So class, it means what? Class, in fact, that is, in fact, we have shown, that is, in fact, class, we have shown that mod Fa, this is a sandwich position. You understand it. This is we are in a now sandwich situation. So it means, class, I have shown you that, yeah. Mod of FA is equal to this. Is this okay,
Yes,
class?
sir. Yes, sir.
Right. Okay. Now, class. Uh, uh, or class, I can write it like this: 2 pi r is equal to gamma mod of fz dz. You can see that I have just done simple algebra. Or class, I can further write it like this: mod of fa, class 2 pi r is nothing but this is constant, class, take a note. And now I take the integration over gamma. So class, if you notice, the this actually this is nothing but this complete thing. This is nothing but just the length of the curve gamma, right, class? Which is nothing but 2 pi r. Is this okay?
Yes, sir.
Right? So this is so, and this is equal to this. So some sort of intelligent manipulation. Or class, this implies that now uh, gamma mod of fa, and using the simple algebra of the integration theory, uh, sorry, plus this modulus dz, this is equal to what, class? This is equal to
0.
0, right? Okay, class. Class, now we have z minus
एक बार थोड़ा ऊपर करना.
a is equal to, right? Oh, sorry, ये सब यहाँ पर लेंथ्स हैं इसकी. सॉरी क्लास, ये सब लेंथ्स है. इज दिस ओके? ठीक है? इज दिस ओके?
Yes, sir.
ठीक है.
Yes, sir.
Okay. So now we have this is equal to EIT, class, because I am talking of these jets. Class, these jets are on this circle, na, gamma. So the equation of this circle is that any point on this circle is this, na, class. This is any z on this circle. Is this okay, class? So now we have z minus a is equal to REIT. This implies that, class, dz will be equal to I R E I T dt. Is this okay?
Yes, sir.
And modulus of dz will be equal to R dt, because I hope you understand it that modulus of I will be 1 and modulus of e to the power it will also be 1. Is this okay, class? And because r is positive, so modulus of r will be same as r. Is this okay?
Okay, sir.
So on making these substitutions, so therefore on making these substitutions from 2, we have, so we have the following thing. So now we are going to change everything in terms of this real parameter t, if you notice. So this is, so the real parameter t, so dz is r dt, and this real parameter t, you know that will vary from 0 to 2 pi, so that the circle may be formed. If you remember in the definition, yeah, this was the range for the real, this parameter t, right, class? Is this okay, class? Now,
Yes, sir.
and uh, this is r, and this is mod of fa minus mod of f, and instead of z here, this, now I'm going to replace this z by a plus REIT. Is this okay? So we have this. So this is equal to 0. So we have made these substitutions. Now, class, take a note. Because r is just real, and you know that r is always greater than 0, radius hai, right? So you can take r on this side, and it will get dissolved into 0. 0 upon r will become 0. Is this okay?
Yes, sir.
right? So, or I can say, or 0 to 2 pi mod of fa minus mod of f of a plus reit modulus mod dt is equal to 0. Okay, class. Now take a note. Uh, class, note that. So let me call it number 3. Note that this minus f of a plus re G is continuous, this is GT, right? And the value of the integral of GT is 0 in number 3. Is this okay, class? Is this okay? Is this okay, class?
Yes, sir.
So
सर प्लीज एक बार रिपीट कर दीजिए जो आपने लास्ट पॉइंट बोला.
बहुत सारी चीजें हो गई. ओके, ये वाला जो रिजल्ट है ये आप लोग पढ़ के आए हैं, ठीक है?
यस सर.
Yes, sir.
अब आप समझने के लिए इस फंक्शन को जीटी कह लीजिए. ये जो अभी अभी मैंने कहा जीटी, मैंने कहा इसको, ठीक है ना, क्योंकि ये वेरिएबल टी का फंक्शन है. इज दिस ओके?
यस सर.
अब ये देखो, क्या ये जीटी है? जीटी तो है ये.
हाँ.
क्या ये जीटी है ना? जीटी है ना? तो ये देखो,
यस सर.
ये आपका जीटी ये तीनों कंडीशन सेटिस्फाई कर रहा है. जीटी कॉन्टिन्यूअस है आपका, अभी अभी बताया जीटी कॉन्टिन्यूअस है.
यस सर.
आपका 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 जो जीटी है वो ग्रेटर देन इक्वल टू 0 है. देखो ये बताया अभी
यस
अभी
सर.
ग्रेटर देन. और आपके जो जीटी का जो इंटीग्रल है वो 0 है, वो एक्सप्रेशन नंबर 3 है. तो ये तीनों चीजें आपको अवेलेबल हो गई. तो अकॉर्डिंग टू दिस रिजल्ट व्हाट यू कैन से अबाउट जीटी, दैट, है ना?
आइडेंटिटी
अब ठीक है, क्लियर है? इज दिस ओके नाउ?
इक्वल टू 0.
ठीक है ना भाई? अब तो
यस
ठीक है.
सर.
ओके. Consequently, GT is identically equal to 0 on closed interval 0 to 2 pi. Is this okay? That is, GT तो आपको समझाने के लिए लिख दिया था मैंने. That is, मुद्दे की बात क्या है? That is, it means I am saying that the value of f at a plus r e I t, its magnitude is equal to mod of fa for all t in the closed interval 0 to 2 pi. Is this okay? Is this okay?
यस सर.
Now what was this? This was an arbitrary point z on the circle gamma. Right?
यस सर.
So it means what I can say? That is, I can say this is equal to this for all z in this. So instead of writing it in terms of the variable, now I am writing it in terms of the points of the circle gamma. It means that the value of the function at all points of the circle is this. Is this okay? Is this okay, class? Is this okay?
Yes, sir.
यस सर.
So what I have shown you, see, I have done a little exercise. In fact, I have shown you that the function is constant at the points of this circle. At least I have been able to show you this. Yes or no? I have shown you that the value of the modulus of fz for all z's on this circle is coming out to be same.
Yes, sir. Constant.
Is coming out to be the same means constant. This whatever the value is there for all z, we are having the same value. Is this okay? Is this okay?
Yes, sir.
Now see, I will repeat this exercise. See how I am going to repeat this exercise. Now what I will do, now please try to understand the mechanism first. So we have this kind of situation. See, I am making the picture. Try to understand the mechanism first. We had some G. This was some G, open and connected. Then inside this, I took a point A, and around this A, because of the openness of G, I could say that there will be some open ball having radius r centered at A, so that that ball will be fully sitting inside G, right? Then what we did, then I took another open ball. And this was also centered at A, and I took this ball so that even the closure of this ball, and its radius was R, even the closure of this ball was sitting inside this bigger ball. Right, class? I took this.
Yes, sir.
Is this okay? Now, class, what I am going to do? In fact, I am going to cover up this bigger ball. This is ball BAR. This is ball BA small r. I took its closure. So class, take a note. I have told you that my approach is that first I will be showing that our function is constant on this ball, and then I will be extending it to this whole G, that my function is constant on the whole G, right? I will use a very simple extension technique. But to show that our function f is constant on BAR, this is my first aim, na class? If you recall, this is my first aim, that f is constant on this. This is my first aim, right, class? So for this, what I am going to do, class, I am going to use a very nice mechanism. If you notice, I took this small r arbitrarily, smaller than capital R. Yes or no, class?
सर कैपिटल बी आर के अंदर सभी चीजें कांस्टेंट हो जाएगा वो तो.
Yes, yes. So class, what I am going to do, I am going to take another circle of some radius, let us say some radius s, and the discussion which I have made for this, I can do that for correspondingly for a circle with radius s also. Yes or no?
Yes, sir. Yes, sir.
And this way, what I will be doing, I will be considering all such circles. I will be doing this process repeatedly. And consequently, what will happen? Consequently, I will be able to show you that on all the points of this ball, function is always taking value how much? Mod of FA.
Yes, sir.
Right? So I will be doing this process repeatedly. And then what I will do, class, then this is inside. And then what I can do, I can allow this R, because this R was arbitrary, I can allow this R to go to capital R. It means I will start extending this process towards outside, and consequently it means what, class? It means that I shall be covering these circles outside this also.
सर ऐसा क्यों सर? बिकॉज सर आर स्मॉल आर जो था वो तो सर कैपिटल आर से सर छोटा था ना.
नहीं, but I can cover up this from inside ना. मैं अंदर की तरफ से पूरा सटा दूंगा.
अंदर पूरा हो जाएगा. ठीक है.
हाँ, मैं ये कर रहा हूँ. मैं आर को बड़ा, अब मैं स्मॉल आर को धीरे धीरे बढ़ा रहा हूँ कैपिटल आर की तरफ. ये कर रहा हूँ मैं, समझ गए?
ओके ओके ओके, ठीक है सर.
यस यस यस. तो मैं ये प्रोसेस रिपीट करूंगा, एंड अल्टीमेटली क्लास इस प्रोसेस से क्या कंक्लूजन निकलेगा कि पूरे के पूरे बी ए आर के ऊपर फंक्शन की वैल्यू क्या आ रही है हमेशा?
एफ ऑफ ए.
यस, ये आ रही है. ये मेरा आइडिया है. ठीक है. तो जब मैं यहाँ पहुंच जाऊंगा, फिर उसके बाद मैं उसको जी के ऊपर लेके जाऊंगा. क्लियर है क्लास अप्रोच?
यस सर.
चलो बस अब आगे बढ़ते हैं.
यस सर.
ओके. तो मैं मतलब अभी मैंने जो प्रोसेस किया, आई एम जस्ट गोइंग टू रिपीट इट. लेकिन और उस रिपीटिशन का इफेक्ट क्या होगा वो मैंने अभी आपको पिक्टोरियली आई हैव मेड यू अंडरस्टैंड दैट. ठीक है. ओके, चलिए अब कुछ आगे बढ़ जाते हैं. लाइकवाइज, इफ 0 is less than s less than r, then considering this, we obtain for all z belonging to the ball, we can say it gamma s. What is gamma s, class? Here gamma s is a plus s eit, this circle. Is this okay, class? ठीक है. Is this okay?
Yes, sir.
Right? Okay, now see. So class, consequently, mod of fz is equal to, I have already explained you this consequently, I will go on repeating this process. For all z such that mod of z minus a is less than equal to r is less. It means class, all this is covered now. Is this okay class? Taking circles again and again. Is this okay class?
Yes, sir.
All this is covered. Okay. Now, now, so class, that is, so class, you see a beautiful interpretation of this expression. Class, these are images of Z under F. Usually we denote images by W. Images are usually in the W plane, right class?
Yes, sir.
Suppose this is Z plane. Now see class, that is, class, can I say, so basically class, you can observe this as mod f is equal to alpha kind of circle, where class, mm, uh, uh, where uh, W means images of Z under F, and class I am calling alpha to this. Is this okay class? So you look at this expression like this. Is this okay class? Is this okay? It means class, these images are satisfying the equation of a circle whose center is whose center is 0 and radius is alpha. Isn't it class?
Sir, can you please repeat it again?
Okay. Class, fz's, usually we denote fz's by w, right? Images. Fz's
Yes, sir.
means images, right? So instead of fz you write w, and this is nothing but a constant c, which I am underlying right now. This is just a constant class, right? You denote it by alpha.
Yes,
So
sir.
class, this expression is appearing like this. It means, don't you see that these fz's, these are fz's now? It means all these fz's, yani it means all these images are lying on this circle.
Yes, sir.
They are satisfying the equation of this circle na. So I am taking a correct interpretation of this expression now. So it means it is appearing that corresponding to, for all those jets which are satisfying this condition, their images are satisfying this condition. It means the images are lying on this circle whose center is 0 and radius is alpha. Yes or no? It is appearing like this. A beautiful interpretation of
Yes,
this
sir.
expression. Is this okay?
Yes, sir.
So I am writing this. So that is, fz is, they are lying on the circle, this. They are on this circle where alpha is this, for all z's satisfying the condition, for all those jets which are satisfying this condition. So it means class, all those jets which are satisfying this condition, their images are lying on this circle. Is this okay? Is this okay?
Yes, sir.
Now class, you see. So a phenomena like this is happening class, you see. It means class, phenomena like this is happening. See, class, you have In the z plane, you have A here, this is R, and uh, satisfying this is condition 5. Condition 5 means class all those points which are inside it, yes or no, and on this. Is this okay, class? Condition 5 means this set, yes or no, class? Condition 5 means this set. Is this okay?
Yes.
So it means the image of this set here in the W plane is what, class? This is coming out to be a circle centered at the origin and having radius alpha. So the image of this complete set is coming out to be this circle, class. Is this okay, class? Is this okay, class?
Yes, sir.
Yeah, so this is, I mean, this is really beautiful reading of this kind of expression. Now, class, take a note. This R was arbitrary, smaller than capital R. So, class, now I am performing this limiting process. So, just I am going to write this limiting process in the form of the following sentence. Now, for R in between this, so that this was sitting inside BAR was arbitrary. You can simply, okay, anyway, it's okay. It's arbitrary. So we may conclude that. So we may conclude that, sorry, class. So we may conclude that. So class, if we adopt this kind of limiting process, it means, class, we are going to declare that this whole ball of radius capital R, if we are going to extend small r to capital R, that it means this whole ball will be going to this, because class, if you notice, in this image there is no involvement of small r or capital R, yes or no, class? Yes or no, class?
Yes, sir.
This ball is independent of small r or capital R. This ball is depending only at 0 and alpha. Alpha is fixed. That is nothing to do with small r or capital R. So we may conclude that this whole ball is being mapped onto the circle, this, in the W plane. So actually, class, I have written this limiting thing in terms of, in the form of this text. Is this okay, class? Is this okay, class?
Yes, sir.
Yes.
Now, class, you see one thing. But while doing this, something devastating has happened. And what is that devastating, class? Class, now you see. Class, just for the sake of imagination, class, there will, you can consider some circle like this here. You can consider some line here like this along the radius, right, class? Right, class?
Yes, sir.
So if you call this, so if you notice that this line segment as well as this circle, each and everything, whatever that is being mapped onto this circle only. Is this okay, class? Yes or no?
Yes, sir.
But class, interestingly, if you notice, what will be the angle between this circle and this line? All of you know this. If this is along the radius, then this angle will be of 90 degree. All of you know this. Yes or no, class? The radius makes an angle of 90 degree with the tangent to the circle at the point where this
Yes, sir.
radius is crossing. This is basic geometry. But class, so if you consider this is one, this is, you consider, suppose this is one pre-image. You call this as curve C1, and you call this line segment as curve C2. So class, it means the angle between C1 and C2 is 90 degree. Yes or no, class?
Yes, sir.
But class, their images are being plotted into the same circle. So can you tell me what will be the angle between the image of C1 and the image of C2? That will be simply, certainly not 90 degree. That will be simply 0, because they are being overlapped now. Because whatever C1, C2 you take, the images are always lying on this circle. Yes or no?
Yes, sir.
So class, it means what? It means, class, this implies that F is not an angle preserving map, is not an angle preserving map from BAR onto this circle. Yes or no, class? Yes or no?
Can you please explain it once again?
Class C, what is happening? Once again, I am making this picture. Class, we have seen that this ball, this complete ball A to R, this complete ball, this is being mapped onto this circle in the W plane. Are you clear up to here?
Yes,
Right? Right. So it means what, class? It means, class, whatever you take here, for example, here you take these two curves, C1 and C2. Suppose one curve is C1 and one curve is C2. The angle between C1 and C2 is 90 degree. Is this okay, class?
Yes, sir.
But if you plot C1 and C2, their image will again be on this circle,
Yes, sir.
because the image of everything from here is nothing but only this circle on this side, nothing else. So certainly this is very much clear, obvious, that if the angle between C1 and C2 is 90 degree, then certainly the angle between their images is not going to be 90 degree. Yes or no? Because they are overlapping on the circle, na? On the same circle, right?
सर
Right? Yes.
सर जो W प्लेन में जो सर्कल है
Yes.
उसके मतलब जो Z प्लेन वाला सर्कल है उसके साथ मतलब कुछ पॉइंट अंदर भी तो अंदर भी मैप करेंगे ना
यहाँ पर
नहीं अंदर नहीं करेंगे, वो तो वैल्यूज ए पे जा
अंदर
रही
कोई
है।
भी नहीं, अंदर कोई भी नहीं भाई, यही तो बताने की कोशिश कर रहा हूँ। प्लीज फोकस एट दिस इक्वल। अंदर कोई भी नहीं होगा, ध्यान रखिए, ये अंदर कोई भी पॉइंट नहीं है, ये अंदर कुछ भी नहीं है, सिर्फ जो रेड सर्कल बनाया है सिर्फ वो है, यही बताया है, यही इसी की इंपॉर्टेंस है। अंदर कुछ भी नहीं होगा, इसके अंदर का सारा, इसके अंदर सारा कुछ है, सब कुछ है, इसके अंदर का सब कुछ सिर्फ इस सर्कल पर प्लॉट हो रहा है। तो मैंने बहुत क्लियरली बताया है, मेरी क्लास के बाद इसको आप रिवाइज करेंगे तो बिल्कुल समझ में आएगा, बिल्कुल क्लियर बताया है, यहाँ पर कोई कंफ्यूजन ना मुझे है ना आप लोगों को होना चाहिए। ठीक है?
यस
ओके
सर।
सर।
हाँ, बिल्कुल कंफ्यूज मत होना, बिल्कुल भी क्लियर। ठीक है, तो इसका मतलब हमने देखा कि ये मैप जो है BAR से सर्कल के ऊपर एंगल प्रिजर्विंग नहीं है, राइट? एंड क्लास आपने पढ़ा है कि अगर डेरिवेटिव नॉन जीरो होता है जिन पॉइंट्स पर और फंक्शन एनालिटिक हो तो एंगल प्रिजर्विंग होता है, और अगर एंगल प्रिजर्विंग नहीं है नेगेशन क्या होगा? इसका मतलब
Derivative is
डेरिवेटिव
0.
जीरो और ऑल जेड्स इन बी ए आर, यस और नो? ठीक है,
Yes.
इट मीन्स क्लास व्हाट? दिस implies that fz is equal to some constant on BAR. So I have shown you that on BAR it is constant. Is this okay? Right?
Yes.
And now the final step. Now I am to claim that actually f is constant on G.
Whole domain G.
Yeah, on the whole domain is constant on G. So see what kind of extension technique I'm going to use here. So for this class, I'm defining a function. Now consider, or you can say define. Just a minute, please. Class C. Consider a function h defined on G into C, and we are defining the function like this: fz is equal hz is equal to fz minus C. Let's take a note. This C is this C. Is this okay? Class, don't forget that BAR is contained in G, right? So class, on BAR, FZ is same as C, right class? Just now we have
Yes,
established,
sir.
right? So class, it means that is HZ will be equal to 0 on uh, on BAR. That is for all Z in BAR. Is this okay? Is this okay?
Yes, sir.
Right? And now class, take a note. F was analytic on the whole of G. C is just a constant function, so it is analytic. So this I can write easily, that clearly H is analytic on G. Is this okay? Okay? Is this okay? And class, if H is analytic on G, this is contained in G, so automatically, uh, so obviously H is analytic on BAR, because BAR is just a subset of capital G. Yes, this is trivial. Is this okay? Now, class, you use that classic theorem. We did a theorem. This was theorem 3.7, which says that if you have a function f from G to C, G is open and connected, and G is analytic, class, then if you remember, we did a result which says that the following conditions are equivalent. Then the following are equivalent. So the first condition was that f is identically equal to 0. The second condition was that there exists a point A in G such that uh, fn A is equal to 0 for all n greater than equal to 0, and the set Z, collection of all those points in G at which the function f vanishes. This has a limit point in G. Do you remember this result, class?
Yes, sir.
In G, right class? So now what you do, class, you take an analogy. Class, instead of G, you take BAR. You set an analogy. So class, this is open ball. Open ball is connected always. I showed you perhaps in the beginning that in fact it is convex. You take any 2 points, you can join them with the help of a line segment. So it is open and connected. Is this okay? Our function h. Now you take f to be h. Is this okay? Is this okay? H is h, right? And h is analytic on this,
Yes.
right? And just now I have shown you that h is identically 0 on BAR. It means on this. This just now I have shown you, right? So if you set the analogy, then class, point number B, you according to point number B for h, what do we have? It means, therefore,
And a derivative at A is equals to 0.
yeah. So there exists. So let us write it properly. There exists some B in this ball such that the nth derivative of this at b0 for all n greater than equal to 0. Is this okay, class?
Yes, sir.
Right? So I am writing this. So therefore, by theorem 3.7, we have h and z is equal to, sorry, we have that there exists some point B in BAR such that h, the derivatives of all orders of h, this B will be 0. Is this clear, class? Is this clear, class?
Yes, sir.
हाँ yes sir ठीक है.
Clear? Now, class, see a little twist. Now, or we rewrite the above as there exists a B in G. Class, take a note. This is contained in G. Yes or no?
Yes, sir.
Yes, sir.
So I can say there exists a, so our this B, it is the same B. It is in G, such that remaining is same. Is this okay?
Yes sir.
And now, class, this time you have B available. Now see, don't you think it is B?
Yes, sir.
The
So
constant
if you
0
have
will
B, then B implies A because they are equivalent. So class, it means what?
f
It
is
means,
H is identically equal to 0.
and now this is identically equal to 0 on G.
On
G.
G.
Right, take a note. Now it has gone to G. Is this okay, class? Very nice technique. This implies that H is identically equal to 0 on G. Is this okay? It's a very nice technique. Is this okay? Right?
Yes, sir.
And this implies that what was H? H was Fz minus C. It means Fz is identically equal to C on G. And hence done. This is exactly what we wanted to show, that F is constant on G. Right, class?
Yes sir.
So class, I think we should stop over here. So today I have given you this very amazing result, what is called as maximum modulus theorem, which says that if we have an analytic function defined on an open and connected set, and suppose the function is bounded and attains its bound, then there is no choice for the function but to be a constant function. Okay. Okay, let's stop over here, class. Oh my